In this lecture, we are going to look at part 3 of our definition of personal data. This includes identified or identifiable. So we will define what identifiable means. We will then look at a threshold for identification. And then we are going to look at 3 different types of data: anonymized data, pseudonymized data. We're going to look at the process of pseudonymization, and then finally aggregation. So what does identifiable mean? Well, a natural person is identifiable when identification is possible. Now, we have 2 different types of identifiers. We have a direct identifier, such as our name. Our name directly identifies us. And we have indirect identifiers. This could be something like an IP or Internet Protocol address. Now, we're going to talk about IP addresses toward the end of the course, but in short, an IP address identifies your device on a network. And depending on how often that IP address changes, or whether or not that IP address is combined with other data, whether that data is aggregated or combined, then an IP address on its own may not identify you, whereas an IP address that is aggregated with other information, such as your internet service provider account number, would be able to identify you. We also have data in aggregate. Now, the idea behind data in aggregate is that one piece of data on its own may not identify you, but if we have 3 pieces of data, such as your birth date, gender, and zip code, then we may be able to identify a person with a high degree of accuracy. And the combination of birth date, gender, and zip code, this example actually comes from a pretty famous study that I believe was done in the early aughts, so the early 2000s, if not maybe the late 1990s, I don't quite remember. But if I recall correctly, I think the scholar's last name is Sweeney. It might be Latasha Sweeney. But she ran this study where she took these 3 pieces of data, birth date, gender, and zip code, and she was able to identify 80% of Americans with just those 3 pieces of data. So again, this is a famous study. This is an example you hear a lot of in the privacy world. And if you Google that up or use your search engine of choice, again, Latasha Sweeney, that paper will almost certainly come to the top. And so do or don't we have any bright lines here that can help us when we're actually doing the work of trying to determine whether or not a piece of data is identifiable data or not? Well, there is a useful recital in the GDPR to help with this, and it's Recital 26. And the main idea here is that if there's a hypothetical possibility that this data may identify an individual, then that hypothetical possibility alone does not mean that the data is identifiable. Instead, what we need to consider is reasonableness, that is, all of the objective factors. And when the possibility is negligible, even if it's 0.01% or what have you, then the person is not identifiable. And so now we come to anonymized data. Now, for the GDPR does not apply to anonymized data. And anonymized data is when all personal identifiers have been removed. However, complete anonymization is very difficult. The standard for the GDPR for anonymized data, that standard is very hard to hit. And so most of the time what you come across is instead pseudonymized data. And with pseudonymized data, this is where direct personal identifiers have been removed. And this helps to satisfy data minimization requirements. The GDPR, however, still applies to pseudonymized data. And so on the exam, or perhaps in some practice questions, you may be asked for the technical definition of pseudonymized data. Remember, this is when personal identifiers have been removed. And so once we remove those identifiers, we have data that is de-identified. But if that data is combined with other data, such as those personal identifiers, then that data is considered pseudonymized. And so the process of pseudonymization, this is when data is unattributable to a specific data subject, again, without additional data, as I just explained. So again, direct identifiers may be removed. The unique identifier may be hashed. When we hash data, that's a process of basically turning it into gibberish. And that gibberish, that unique combination of gibberish, That may be kept in a separate, what's called a lookup table. And with that lookup table, we could say, all right, well, this gibberish actually equals this number or this name. Now, with regards to aggregate data, this is where we are combining data from multiple sources. Then we organize or summarize that into a high-level format. Examples include taking all of the number of flu cases in a city over a month. We may be able to say that, all right, well, in this city for the month of November, we had 150,000 flu cases. Of those 150,000 cases, we had so many mortalities. We had so many people between the age of 1 and 10, 11 and 20, and so forth. Other types of aggregated data might include total retail sales by product category, average credit score of loan applicants, and total page or post views on social media. In this lecture, we went over part 3 of the definition of personal data. We looked at identified or identifiable. Remember that a natural person is identifiable when identification is possible. When it comes to trying to determine whether or not a piece of data is considered personal data, remember that if there's a hypothetical possibility that this data could be used to identify a person, that hypothetical possibility on its own is insufficient. Instead, we want to consider reasonableness and all objective factors. Remember that anonymized data is when all personal identifiers have been removed. Complete anonymization under the GDPR is difficult. What is more common is pseudonymized data. This is when direct personal identifiers have been removed. This helps to satisfy the data minimization requirement. The GDPR still applies to pseudonymized data. It does not apply to anonymized data. Pseudonymization, this is when data is unattributable to specific data subjects without additional data. And finally, aggregation, this is the combination of data from multiple sources, and then the organization or summarization of that data into a high-level format.